Hey guys, it's Chris at Highline Guitars. Welcome to my YouTube guitar building channel. Today's video is going to be the first in probably a series of videos where I'm going to do my best to try and explain the CAM strategies that I use when carving a guitar on a CNC machine. And I'm going to start out with this episode explaining the strategies that I use for making a fretboard. And then in future episodes, I'll talk about the neck and then the body itself. So let's jump on the computer and get started. What you see here is a full-size, full-scale top view of one of my fretboards. And this drawing was created in Adobe Illustrator. In truth, you can use pretty much any vector-based program or a CAD program, and of course CAD stands for computer-aided design. You just have to make sure that whatever program you use, you can export as an SVG file, and I'll explain why in a minute. You also need to be able to save it in a format that a 3D design program will recognize. And I'm using Rhinoceros 3D to create my 3D models, and it recognizes the native Adobe Illustrator format. So I can import the elements that I need directly into Rhinoceros to build those 3D models. Now, the question is, why all these different formats? Why do I need SVG and then a 3D format? Well, the SVG format works great for any sort of a two-dimensional carving operation. And that would include, for example, fret slots or fret marker dots. In the case of a guitar body, that would include pockets for the pickups, the controls, the neck, the perimeter shape of your guitar. Anything where you're cutting pretty much straight down into the wood and there's no three-dimensional contour involved. However, wherever you do have a three-dimensional contour, and in the case of a fretboard, that's going to be the radius. In the case of a neck, it's going to be your back contour. And with respect to a body, you might have a carved top or comfort contours like a belly relief or arm contours. Anytime you have those angled three-dimensional shapes, you need to build a 3D model in order to begin the process of establishing the CAM strategy for those type of carvings. So that's why you need to have SVG and the 3D files that are necessary for this. There are several concepts which I think are important to understand with regards to how I set up my CAM strategies. When I create a drawing for one of the parts, whether it's the fretboard, the neck, or a body, I always make sure that those drawings are centered in a document that is sized to match whatever blank I'm going to be carving that part out of. So in the case of this fretboard, it's 3.5 inches wide and 22 inches tall. So the blank I'm going to be using will be the same size. Also, the elements of the drawing, and that's everything that makes up the fretboard, is centered exactly in the middle of this document. This is important because I'm going to be doing a number of different carving operations to make this fretboard. The number of carving operations is going to depend on how many bits that I have to use to do this. And in the case of this fretboard, I'm going to be using 4 different bits, so there'll be 4 different carving operations. Now, to make sure that each operation is positioned properly with respect to the previous carving operations, I want to make sure that all of the carving operations are centered within the blank. And my work 0 position for all of my carving operations is going to be in this lower left corner. So once the, for example, the operation for carving the marker dots is complete, the spindle will return to that lower left corner. There I can replace the bit with the bit that I'll use to carve the slots. And so I want to make sure that everything is going to be positioned correctly. And I think it's just good, it's a good practice to make sure that your drawing is centered within the blank. So this also is going to play a pivotal role later on in future videos when I talk about how I do two-sided carving. So it's just a good practice to make sure that whenever you create these drawings, they're centered within the document size, and the document size should be exactly what your blank size is. Once I have finished my top-down, full-size, full-scale, two-dimensional drawing, I can save out the elements in the appropriate file formats and begin the process of developing my CAM strategy. So, as I said before, there will be 4 different carving operations, and that's because I'm using 4 different bits to cut the fretboard. So I'm going to have one operation for drilling the fret marker dots as well as this slot up at the top where the nut will be installed into the fretboard. Then I will have another carving operation to cut the fret slots. Then I'll have a carving operation to do the radius of the fretboard, which in this case is 12-inch radius. And that again is going to be a 3D carving operation. And then finally, I will have a perimeter carve to cut out the shape of the fretboard. So 4 different carving operations. And I will save out my marker dots as an SVG file as well as the fret slots. And then the radius and the perimeter will be done separately as a 3D carving operation, which I will explain in a little bit more detail in a few minutes. The first operation that I have to perform in order to carve this fretboard is a simple 2D carving where I will be cutting out the holes for the fret marker dots as well as the slot for the nut. And since this is a simple 2D carving operation, it's going to be done using an SVG file, as I mentioned before. And I save that out separate from this file. And this is what the SVG file looks like. It basically has the elements that I'm going to carve for this particular operation, the holes for the marker dots as well as the slot for the nut. And as you can see, it's set up on the same document size, 3.5 inches wide, 22 inches tall, that the original fretboard design was based on. And the purpose of this is just to keep every operation on the same size document so that everything remains registered and in line. So to help in achieving that, I've drawn a rectangle which is the same dimensions as the document itself, 3.5 inches wide, 22 inches tall. That way, when I place these different elements, they're always going to be registered within the center of that document size, and nothing's going to shift or move around. And it just makes it really simple for setting things up. And I think you'll see that here in just a second. So what I'll do then is, with this SVG file, is I'm going to place it into Easel Pro, which is the CAD/CAM software solution that was developed by Inventables for use with their X-Carve Pro CNC machines. Now, this is an online program, so it's available for use on, via your browser. So you would set up an account, and with Easel Pro, it's a subscription-based software solution. It's very affordable though, and they do have a free version, which is just the basic easel. I use the Easel Pro because I like its features with regards to simulation. It lets me really check out what I'm doing before I actually do it. But this is a file that I have created for one of my Bravo guitar designs, and this includes the fretboard, the neck, the body, and a couple of other parts. And you can see all these pages at the bottom of the screen, and each one of these is a different carving operation. So I'm on the first page, which is down all the way at the lower left, and this is a page that I have set up the project file that will be for cutting those marker dots in the nut slot. So if you look at the upper right side of the screen, this is where I set up the material dimensions. And again, as you can see, I'm following the same dimensions that I set up when I created the file in Illustrator. It's 3.5 inches wide, 22 inches tall. But here I was able to set up a thickness of 1/4 of an inch, which is what I pretty much do all my fretboards in, but it's also what I set up my 3D model for the radius, which you'll see a little bit later. And then for material type, I selected hard maple, which is pretty representative of all the different types of woods that we use for fretboards. So that's what I'm going to use for that. Now, what I will do when I set up this file is it creates on the left side of the page a top-down view of our document. And again, 3.5 inches wide, 22 inches tall. So what I can do here is I can place my SVG file into this document like so. And because I have that bounding box, everything is positioned exactly where it needs to be. But I don't need the bounding box. If I were to leave that in there, the CNC machine is going to actually try to carve it. So I can delete that because I don't need it. And then to drill out these holes or to carve out the holes and to cut the slot for the nut, what I'll do is I have several different path strategies here. I can clear out a pocket, I can cut on the shape, cut outside the shape, or cut inside the shape. Well, since these are pockets, I'm going to set it up as clear out a pocket. Now the depth of this pocket, it's going to really depend on the thickness of, for example, the material I'm going to inlay for the marker dots, or how deep I want to place the nut into the fretboard. And really that's something that there's no real answer. It can be pretty much whatever you want it to be. So what I'm going to choose is 0.125 inches, which is 1/8 of an inch deep. And that will set that depth. Now what I have to do is I have to choose the right bit to carve this. So up here in the upper right corner where it says bit, I can choose from a variety of different bits. Now some of these bits are the standard bits that are the default options when you first set yourself up with Easel. But what you can do is you can add bits, and you can either add bits that are available directly from Inventables, or you can add your own bit by setting up parameters. You give it a name, select the bit type, and you can then, do the cutting diameter, that sort of thing. So I've already done that, and I have created a 1/16 inch 2-flute spiral upcut bit, which is the bit that I'm going to use to carve the marker dots and the nut slot. If I were to try to use something larger, like a 1/4 inch bit, it's not going to carve it. It can't, because the holes in the slot are too small. So it has to be that 1/16 inch bit. And you can see that in the preview here on the right side of the screen, that it's actually going to be able to do that with this bit. Then as far as cut settings are concerned, you can either do an automatic setting where Inventables oftentimes, depending on the bit, it's usually with the bits that they sell, they have recommended feed rate, plunge rate, depth per pass, and that sort of thing. I set mine up manually, and this is based on experience. I know that with a 1/16 inch bit, I can run a feed rate of about 60 inches per minute, a plunge rate of 24 inches per minute, a depth of cut of 0.0625 inches, which is equal to the diameter of the bit, and then a spindle speed of 20,000 RPM. Then for the fill method, I use this offset, and this is basically a climb cut because it's moving in a counterclockwise fashion. So it's a climb cut, and I get pretty good results with that. So that's typically what I'll stick with. I do that with pretty much almost all of my cuts. And I also will use a ramping strategy. And what that does is it slowly introduces the bit by gradually plunging it into the surface rather than plunging it all the way into the full depth per pass. It just sort of gradually reaches that. And that's a good safety feature for protecting your bits from getting damaged, especially if you're carving in really hard materials. Slowly ramping it in will allow you to use that full depth of cut, but without the risk of pushing it too hard and breaking the bit. So with all that figured and input, I can then do a simulation, and that tells me it's going to take me 2 minutes to cut the holes for the marker dots and the nut slot. So when that's done, the next page that I cut, the next operation, is to cut the fret slots. And this is placed in there just exactly the same way as I did the marker dots. The file is dropped in with a bounding box so that it's placed perfectly, so that when these slots are cut, they register perfectly with the marker dots. But I, of course, will delete that bounding box once I get it placed in there. And then what I'll do is I will change my bit, and this time I'm using a 0.024 inch 2-flute spiral upcut. And again, I set this one up myself, and it's always available to me whenever I'm setting up my cutting operations. I can choose from this bit. The cut settings are obviously quite a bit different than the 16th inch bit because this bit is so much thinner in diameter. So the feed rate is 20 inches per minute, plunge rate 15 inches per minute, a depth per pass of 0.01 inches, and then the spindle speed is 20,000 RPM. And again, I'm using that climb cut counterclockwise movement of the spindle. And then I'm using a ramp of 20 degrees. 5 degrees is a little too shallow for such a narrow area, so I use the 20 degree, and that seems to work fine. So when I calculate the estimated time, it's about 31 inches, or 31 minutes, as you can see in the lower right corner down here. So that's how long it will take, and this is cutting to a depth of 0.125 inches. In truth, the depth of the cut should match the overall depth of the tang on the fret that you're pressing in or will be pressing into the fretboard. I just have it set at 0.125 as kind of a standard, but before I actually carve it, I will measure my fret wire depending on the wire I'm using and where I got it from to see exactly what that the depth of that tang is, and then I will adjust that cut depth to match that. Maybe a little bit more, because in the end, after I have cut out the fretboard and it's finished, I might do a very light sanding on the radius surface to get rid of the potential for tool marks. And that really depends on what I'm going to be showing you in the next step, as well as the type of wood that I'm using. But I just want to make sure that the slot is going to be deep enough to accept the fret so that the tang doesn't bottom out in the bottom of that fret slot depth. Once the fret slots have been carved, it's time to move on to the next operation. And as you can see, this page looks very different than the previous one. And that's because what we're going to be doing here is carving the fretboard radius, and that requires a very different process. Since this is a three-dimensional shape, I have to create a 3D model. And of course, I used the elements from that fret design that I created in Adobe Illustrator, but I imported those into Rhinoceros 3D to build a 3D model of the fretboard with its radius. Now, I'm not going to explain the specifics about how I do that. This will be probably something I'll cover in a future series about building 3D models. But basically, this is what it comes up with when it's finished, when I've created the 3D model. And then once I have this, I can export it as an STL file, which stands for stereolithograph. And the reason why I have to export it in that format is because I'm going to import it into a CAM software to set up and establish my tool paths. And that program is called MeshCam, which is this program right here. And that's what the fretboard looks like when I bring it in. Well, not quite. It's close to this. I've done a few things to get things prepared for carving. I added tabs along the sides here, which is these red bars. And what that does is it keeps the fretboard secured to the blank while it's being cut out, so that when your bit cuts all the way through, the fretboard doesn't suddenly go flying around and get damaged. So I set this up in MeshCam, and MeshCam requires the file format to be an STL. That's why I exported it that way from MeshCam. So I'll open it up in this. Again, I will set up my stock size to match the dimensions of the fretboard blank going all the way back to my Illustrator file. And that way everything is positioned correctly, because when it creates the stock, which is this rectangle that surrounds the fretboard, the fretboard itself will be centered directly in the middle of that blank. So everything continues to be centered and is always positioned correctly. And then as you can see down here at the lower left side of the page is this kind of multicolored arrows. That's the work 0 position, just like it was set up in Easel Pro. So it's always going to be in that lower left corner. That way, each time a carving operation finishes, it returns to that 0 position. I can swap out my bits and then start from there again, and everything stays registered. Now, there are a wide variety of different carving strategies when it comes to forming a radius like this. Now, typically when we are doing CNC carving operations with three-dimensional shapes, we're going to do two kinds of carves, a rough carve and then a finish pass. The rough carve hogs out most of the wood, but it leaves the surface fairly rough. The finishing pass, however, will clean that up and smooth it out and give you a nice smooth finish that requires very little sanding. However, you don't always need to do a rough cut and a finishing pass together. A lot of it depends on the depth that you're going to need to cut to get the finished surface. And with a radiused fretboard that's 1/4 of an inch thick, since the center of the fretboard along its length is right at that 1/4 inch thickness, where it radius is down towards the edge is just not deep enough to require a full roughing pass. So instead, what I've done is I've set it up with just a parallel finish. And in MeshCam, I have a number of bits that are set up that I use. And these range from my 1/8 inch diameter bit. I've got a couple of those, 16th inch, 32nd inch, 1/4 inch. But I also have some larger ball mills, and I've got a 5/8 inch diameter and a 1/2 inch diameter. And I really like to use this 1/2 inch diameter for a lot of the cuts. And that's what I'm using for this initial carving operation to form the radius. So it's set up with to automatically fill the feed and plunge rate and RPM. And that's based on how I set up the tool, which in this dialog, I can put in the overall length, the shaft diameter, all this information, including desired feed rate, plunge rate, spindle speed, step over percentage, and step down. So that's what I have set up in here. And the applicable settings are then transferred over when I select the bit for this parallel finishing tool path. So 150 inches per minute, 40 inch per minute, plunge rate, and the spindle speed will be 16,000 RPM. The step over is 6%, and it's going to be carving along the y-axis parallel. And what that means is the spindle and the tool, the bit, are going to move along the length of the fretboard, back and forth. Each pass is parallel to the previous pass. And the step over will be 6%. So 6% of whatever half an inch is. I'm not sure what that would be offhand, but that's how far the bit moves over with each pass. And the end result is a very, very smooth surface. So all I need to do is carve that parallel finish. However, before I can calculate the tool paths for cutting the radius in this fretboard, I have to trick MeshCam. And the reason for that is because if I do click the calculate tool paths, what MeshCam is going to do is it's going to generate a tool path, and that's what this green color is. If you look really closely, it's individual green lines. Those green lines represent the center of the bit as the spindle is moved back and forth along the y-axis to carve that shape. However, what it wants to do is it wants to carve the sides as well as both ends. And since this is a 1/2 inch round nose bit, what's going to end up happening is that edge, instead of being straight up and down vertical, is just going to curve out like the bottom of a swimming pool. And we don't want that at all. So what I have to do is I have to trick MeshCam into carving just the top surface of the fretboard radius. And the way I've found to do that is if you look over here on the left menu options, on the left side of the screen, we have distance around geometry, and it's set to 1/2 inch, which is the diameter of that round nose bit that I'm using for that parallel finish. So what I'll do is I'll just type 0. And what it does is it populates that field with the minimum measurement, which is 0.0001 inches, which for all intents and purposes is 0 in this situation. But when I hit calculate toolpaths, I'll get a warning saying I really should consider increasing that distance around the geometry to 1/2 inch. But I don't want to do that, so I'll hit no. And what it will do is it will calculate a toolpath that's only going to be on the top surface of that fretboard. And that's exactly what I want. So I can save out just the parallel finish, and I can do so by deselecting the pencil finish. I'll be saving that in a minute. And then I would just hit Save G-Code, and then in this dialog, I can select whatever post-processor matches the CNC machine that I'm using. And since I'm using an X-Carve Pro, Inventables recommends using the basic G-Code -inch. So that's what I would select, and I would hit OK. And then I can navigate out to my fretboard folder, which is where I'm saving all my files for this fretboard. And I would probably just give it a name like 2022 Bravo fretboard radius parallel finish. And then I would save that. Now I've already done that, so I'm not going to bother doing it again. So with the radius toolpath done, I can then finish by setting up the pencil finish. And what a pencil finish is I'm using my 1/4 inch 2-flute diameter spiral upcut bit. And these are all the specifications for that. So that's the bit that I'm going to use. And what it's going to do is cut just the perimeter shape, and it will populate the speeds and feeds, or feeds and speeds, 150 inches per minute feed rate, 40 inch per minute depth of cut, 16,000 RPM spindle speed. And then I will click the cutout checkbox here so that it will only do a cutout. So with that's all determined, I can hit OK. Then what I have to do is I have to go back in here and type 0.25 inches again, because that bit that I'm using for the pencil finish is 1/4 inch in diameter. Or I could actually do 0.5. That will save me from getting that warning dialog. So then I'll click Calculate, and it's going to calculate everything, including the parallel finish, but I can deselect that. And if you look closely here, you can see that green line. That's the pencil finish cutout. So I will save that in just the same way. I'll put it in that same folder, and I'll title it 2022 Bravo Echo Fretboard Radius Pencil Finish. And I'll have all my files ready for the next couple of carving operations for the fretboard. So back in Easel Pro, what I can do is just hit my import G-code and then navigate out to that file and select the correct file, which in this case would be the parallel finish for the radius. And then it imports it just as you see it here. And you can zoom in and see those blue lines represent the movement of the tool across the surface. And when I check at the bottom of the screen, you can see the estimated time. And this time is actually fairly accurate. I've actually timed it with a stopwatch, and it's right on it. So it'll take about 14 minutes to carve that radius. And you can view a simulation of the movement of that parallel finish with that 1/2 inch round nose bit. But then once that's done, the spindle will return to the work 0 position, and then I can swap out the bit for my 1/4 inch diameter 2-flute spiral upcut bit, and I can then carve my cutout. So this takes about a minute. And that's really all there is for setting up and carving the fretboard. Well, guys, that's all the time I have for this episode. Hopefully my fretboard CAM strategies make sense. If there's anything that I didn't cover or you have questions about, post it down in the comments below and I'll do my best to answer it. As you can see, this is a pretty complicated subject. And what I plan to do is additional episodes where I'm going to focus on the neck as well as the body. And what I'll do is I'll put all these episodes into a playlist so that they're all nicely organized together. Hopefully that'll work. At any rate, be sure to give my video a thumbs up, comment, hit subscribe. You know, if you want to help show my channel some support, head over to eguitarplans.com and purchase a plan for a guitar or even the CNC machine that I built. And even if you don't build the plan that you purchase, just know that your purchase is helping to support my channel. And if you don't want a plan but want something cool to wear, down below I've got a merch shelf with some t-shirts. And if you don't see that shelf, there is a link in the description below so that you can go check out the t-shirts and maybe make a purchase or two. At any rate, until the next episode, take care, stay safe, and I'll see you soon.